Hey guys, so continuing our series of taking a peek at GitHub repos or open source projects, I found an interesting tool called Fargate. It's an unofficial command line interface to the Amazon Web Services tool, also called Fargate. And I guess it's authored by this guy, John Pinata, who's an employee at Amazon, I guess. But either way, it's unofficial, not officially supported by Amazon, the company. He's got a pretty nifty demo
In
video
this video,
of
CLI.
how to use it. It doesn't include exactly how to get it set up. For example, like adding your Amazon Web Services credentials so that when you use it on your command line, that it actually creates and provisions your software to be ran on Amazon Web Services. So to give you guys a kind of rundown of what Fargate is, as far as I understand it, is that it's a container running service. Given that you have a Docker file, let's say, and you want to run, Nginx, then what you can do in using this command line tool is run basically Fargate run task Nginx. And what that will do is it'll point to Fargate, say, hey, Fargate, run the Docker image called Nginx. And obviously, you'll want to bring your own. Nginx is just a HTTP web server. You might want to run a Django, Rails, Node.js, Go, whatever it is, on the AWS Fargate service. So taking a look at this real quick, as far as I understand it, the way to obtain the executable Fargate command line tool is to download a zip. And I guess we got to open it, and it'll be in our downloads folder. So if we try invoking Fargate, it gives us a nice little description. Deploy service containers onto the cloud from your command line. Fargate is a command line interface to deploy containers to AWS Fargate that makes it easy to run containers in AWS as one-off tasks or managed highly available services secured by free TLS certificates. So idea being you can SSL encrypt your traffic, which is a must-have these days. It bundles the powers of AWS, including ECS, Elastic Container Service, ECR, Elastic Container Registry. This is the equivalent of Docker Hub. It's just your own personal one on AWS. ELBs, load balancers, Certificate Manager, that's the SSL. CloudWatch logs, that's important to be able to see the logs from your application servers. And Route 53 for DNS. So looks pretty simple. There's only 5 commands. I think the one that we're going to try out today, because I'm sure these other ones are a little bit more involved, is running just one-off tasks. So for our purposes, let's take another gander at his getting started guide. Let's just try running Nginx. So one thing you guys will note is that, one, this didn't work. But for another, I have a few things set up in my environment to properly authenticate myself. So for your guys' purposes, you'll need to set a couple environment variables like your access key ID and your secret key ID. And these are read from the environment when you actually invoke the command line. And that's true of the official Amazon Web Services CLI too. But it looks like we have an issue. Could not run ECS tasks. Invalid parameter exceptions. Subnets cannot be empty. Status code 400, so invalid arguments. So let's take a look at the GitHub repo. Maybe somebody's filed a ticket about this already. We want to search all issues. Default task running doesn't work without additional configuration. Sounds like us. This is exactly the same error. If you provide a subnet, it then complains that security group can't be blank. This guy really helpfully points out, okay, the video is misleading. Fair enough. So we'll need to additionally specify a subnet ID and a security group ID. Well, I'll take a look. Let's go to EC2 to look up a security group ID. Rather than signing into the console here, as some smart-ass audience members might point out, is that you could use the command line interface, and that's totally true. This is kind of a little bit more navigable because I don't have much in my AWS account at this point. So let's look at the default security group. The important thing is that in order to test this, we're going to try, requesting a HTTP web page from the Nginx container we're going to try running. So it's important that the security group we choose is open to traffic on port 80, and this default security group is. So let's get the security group ID, and we'll need to add to our previous command. And we can try running it. It'll probably complain about missing a public subnet. Yep, subnets cannot be empty. So we're going to also need to go, and separate of EC2 is VPC, which manages our virtual private cloud or network configuration. So hopefully I've got a pre-existing public subnet. If not, perhaps we'll need to create a default VPC. This is possibly the most tedious thing about AWS is networking and the let's just do what they recommended. No IPv6 CIDR block? Sure. Okay. Okay, the following VPC was created. Is that this default one? Or is it the unnamed one? I think it's the default one that we just created. So by default, I don't believe that our VPC has a subnet. So we'll need to go first. Let's we can copy to clipboard, and let's try creating a public subnet. We'll call it default, and we'll make it the default one. I honestly have little familiarity with CIDRs, but we created this subnet. I'm not totally familiar with how to make sure that it's publicly accessible to the world, but let's try adding a subnet ID here and try running Nginx. So the security group doesn't belong to the same VPC as the input subnets. That's tragic. So we'll need to, again, pick the VPC ID. And what we'll do is go back to EC2 and create another security group. God, this is the most tedious part about working with cloud services is the networking. And it's so unintuitive too. So here's the VPC part. We'll call it default Fargate test. How about that? And we'll add one rule, which is let's just open it to all traffic. Who gives a hoot? Default Fargate test. The source needs to be a CIDR block or a security group ID. Anywhere. Cool. So now we have a new security group, which is in the same VPC as our subnet. So let's give this a try now. Running task web. So I think there's a way using this command line tool, to list your running Fargate containers. And the only thing you need to do is provide the name of your containers or your tasks. So you can just verify that it's running. Right now it's pending. So it's been 17 seconds since we initially ran run. We have a IP address, which I believe is public. Gives us information about the amount of computing and RAM available to the container. Let's see whether it's transitioned from pending to running yet. It does not. So Fargate, if you type Fargate in, you'll see that it points to ECS. So ECS, Elastic Container Service, is what manages running Docker containers. And so you'll see there's a few tabs here, not very intuitive. First is services, second is tasks. So we ran it as a task, or our Fargate tool is running it as a task. Services are intended for longer running sets of containers that you want to be ran. And it allows you to configure stuff like minimum number of containers running at a time, maximum numbers, even probably associating an auto-scaling group so that it scales up and down depending on, traffic needs or compute needs. So we can hit refresh. Still not running. Maybe it's under stopped. Stopped. Task stopped. I wonder where it went. What's going on? No tasks found. Interesting. Let's try running it one more time. Clearly, this isn't so easy. So status provisioning. As we're waiting, we can just click around and explore the Fargate interface, something that I'm not super familiar with. So I guess there's a default cluster that your container runs in. Keep in mind that Fargate is really a service built on top of ECS, which is in turn a service built on top of EC2 or Elastic Cloud Compute. So our container is running inside of an ECS cluster, running inside of on top of an EC2 compute instance. Task definition. This might be interesting. So the Fargate command line tool we're using auto generates this JSON file, is my understanding, and this JSON file, contains the identifier of our Docker image, for example. So if we search on this page Nginx, there it is, the image that's to be ran as a task. So you can see that there's task definitions, which track the versions of a task as you redeploy an existing task. So that's distinguished from the container. So this is still pending. Interesting. Well, we're not going to dwell on this too long. It's a shame that we can't really prove out that we can bring up a running container, and also that we need to update the docs to include information about specifying a security group and a subnet. But we can take a moment longer just to read their getting started guide. The stuff we're not going to cover is like creating a service as opposed to running a task. Here's a little description about what a service is, distinguished from a task. Services are managed containers that are restarted if a failure occurs. Like a task, you can deploy a service using either a pre-existing Docker container or build and push it using the Fargate tool we're reviewing right now. You can run it behind a load balancer, create MyLB, that's the identifier of the load balancer. I'm not sure how this might differ with HTTP versus HTTPS. Like, you should probably specify HTTPS port. Maybe he'll cover that in a second when it comes to provisioning SSL certificates. So this kind of Fargate tool on the command line, this is something that we could, download as part of our continuous integration and use it for triggering builds when our code looks good and setting up automated deployments. Looks like we can scale up the amount of compute that our service requires. We can scale up the number of instances. We can again use the ps command to see whether our command is running, and we can check that right now. This time using a task. So looks like we're having issues starting it up, and my guess is that it might be due to the security group and subnet that I have, is that it might be trying to perform some kind of health check and failing. If we refresh, you can see it's no longer there, so we need to look at stopped tasks. If we go click on the task, maybe we'll be able to go to the logs and see why it failed to start up. So we can either click here, I'm guessing, or we can click here. So let's go here. There are no logs. That's great. Just debugging this stuff is a freaking pain. Awful pain. Anyways, you can also, they make it a little bit easier for you to provision an SSL certificate so that when you go to, your website, you got HTTPS instead of HTTP. So your traffic's encrypted. Multiple services to a load balancer. So from the same domain, under the different paths, you can direct traffic to different services, which is pretty nifty. You can also use this tool instead of using CloudWatch or the official CloudWatch command line interface to, I guess, query your logs. Let's see if it tails it though. Tail logs using follow. That's interesting. I'm not sure how real time it is, but we won't be able to give it a try because neither our container is starting up or our logs are getting captured, or at least not finding them in the right place. So Sorry, this isn't a more meaningful review, but we got a little bit far. It looks like a cool tool. It looks like Amazon is kind of shooting people in the foot here by requiring you to have all this VPC stuff set up. So that's a shame. Hope you guys enjoyed. If you liked it, like it, subscribe. If you have other GitHub repos or public open source projects you want me to check out, drop them in the comments. I'm happy to check them out. Hope you enjoy.